Hi, welcome back to this channel. In today's video, we are diving into two super important rules in calculus, the product rule and the quotient rule. Have you ever looked at a function that multiplies or divides two expressions and thought, how do I differentiate this? Don't worry, you are in the right place. Now, whether you are a student trying to ace your exams or just someone brushing up on your math skills, by the end of this video, you will know exactly when and how to use these rules with confidence. So grab your pen and notebook, hit the subscribe and the like button, and let's get into it. Now, the definition of the product rule. The product rule is used when you are finding the derivative of two functions being multiplied together. Now, let me take it again. The product rule is used when you are finding the derivative of two functions being multiplied together. So suppose you have a function y equals f of x dot g of x. This is a function multiplying another function. So two functions being multiplied together. Now the derivative of this function dy on dx is equal to f prime of x dot g of x plus f of x dot g prime of x. What does this mean? This means that differentiate the first one, keep the second, then keep the first one, differentiate the second, and after that add them together. So that is how the product rule is used. You differentiate the first function, you keep the second one constant, then you keep the first one constant, you differentiate the other one. After that, you add your result. So in this particular question, we are given our function to be, the first one is y equals 4x squared minus 1 times another function which is 7x cubed plus 6. So we can name our function as f of x, the first one, and name the second one as the second function, which is g of x. So by the product rule, which says that differentiate the first one, keep the second, then keep the first one, differentiate the second one. So in our case, let me reinstate the function again. So we have y equals 4x squared minus 1 times 7x cubed plus 6. And so by the product rule, we are going to differentiate, dy on dx equals d dx of the first function 4x squared minus 1. We keep the second one, so we are going to keep the second one. And so we have 7x cubed plus 6. Then we differentiate, we keep the first one constant, then we differentiate the second one as well. So we are going to have 4x squared minus 1 d dx of the second function, which is 7x cubed plus 6. So you differentiate the first one, you keep the second one constant, then you differentiate the second one, you keep the first one constant. So we are going to have differentiation of the first one is 2 times 4 giving us 8. Then you subtract 1 from here giving us x. So 8x. So the derivative of 1 is, or the derivative of a constant is 0. So we are going to have 8x times 7x cubed plus 6. Then we keep this first one two constants, 4x squared minus 1. We differentiate the second one. So 7 times 3 gives us 21 times x cubed plus, x squared plus, then we differentiate the x, we get 1. So after that, we multiply our results together. So 8 times 7 will give us 56. So 8 times 7 gives us 56. So in our first multiplication, we are going to have 56 x exponent 4 plus 8x times x gives us 8x squared plus, then we multiply this one too by this, but this is a binomial expression or binomial expansion. So in this case, we take 4x squared, we multiply it with the second expression, which is 21x squared plus 1. So 4 times 21 will give us 84. So 84, so 4 times 21 gives us 84. Then x squared times x squared gives us x exponent 4. Then 4x squared times positive 1 gives us 4x squared. Then we take the negative 1 to use it to multiply 21x squared. It gives us 21x squared. The negative 1 times positive 1 gives us negative 1. Then we check through. We have like them. So 56 x exponent 4 and 84 x exponent 4 are like them. So 56 x exponent 4 plus 84 x exponent 4. Then plus we have 8x squared plus 4x squared minus 21x squared. Then we have negative 1 too as well. So negative 1. Then we put the two together. So 56x exponent 4 plus 84x exponent 4 gives us 140x exponent 4. Then 8x squared plus 4x squared minus 21x squared gives us negative 9x squared. Then we have our negative 1 here. So this is the result for the first function. Now with the second function, okay, so now let me clear this. Differentiate the second one too and see the result as well. Okay, so in our second question, we have our function s equals 1 plus t times root t. Okay, so this function is function of x. So our ds differentiates s with respect to t. We are going to have ds on dt equals, differentiate the first one. So let's call this one f of x. Call the second one g of x. So we differentiate the first one. We keep the second one constant. Then we keep the first one constant. We differentiate the second one. So with the first expression or the first function, we have 1 plus t times, then the second one too we have, sorry, yes, so we differentiate the first one, sorry, so we have d on dt of 1 plus t, then we keep the second one to constant times the g of x is root t, then plus we keep the first one constant, 1 plus t times d of dt, d dts of root t. So we know that the root of t or root t is the same as t exponent half. For that matter, if we differentiate the first function, we are going to have the differentiation of this one gives us 1 times root t plus, then we keep this one constant, 1 plus t, then we differentiate this one. So when we differentiate this one, we're going to have 1 on 2. So this is, we multiply the coefficients of t by half. So we are going to have 1 on 2 times t. Then we subtract 1 from the half. Then we have negative 1 on 2. Okay, so we are going to have 1 on 2 times t negative 1 on 2. So when we multiply this, we are going to have root t plus then 1 plus t times 1 on 2 t exponent negative 2. Okay, so now we can simplify this one and simplify this one. We know that this is 1 on t times t exponent negative 1 on 2 is equal to 1 on 2 times t exponent half because of this negative. And for that matter, this one can be written as t plus 1, 1 plus t times 1 on 2 t exponent half. Now 2t exponent half is the same as 2 root t. For that matter, we can rewrite this one as root t plus 1 plus t times 1 on 2 root t. So which is equal to root t plus 1, this 1 plus root 1 plus t times 1 gives us 1 plus t all on 2 root t. So this is the result for our differentiation of these two functions. In this third example, we have our function to be y equals 2x exponent 3 minus 1 all exponent 5 times root x squared minus 1. So let's name our first function as f of x and our second function as g of x. So from the product rule, as already stated, our dy on dx cos, we differentiate the first one, we keep the second one constant, we add it to, we differentiate, we keep the first one constant, we differentiate the second one. So in this case, we have f prime of x dot g of x plus f of x dot g prime of x. Now d dx of the function 2x cubed minus 1 all exponent 5 times root x exponent 2 minus 1 plus, then our function f of x is 2x exponent 3 minus 1 all exponent 5 dot d dx of the second function, which is root x squared minus 1. Okay, now we know that root x squared minus 1 is the same as x squared minus 1 exponent half. So in this case, if we rewrite this one as this, then we are going to have it as d dx of 2 exponent 3 minus 1 or exponent 5 dot x squared minus 1 or exponent half plus 2x squared minus 1 exponent 5 dot d dx of x squared minus 1 or exponent half. So when we differentiate this one, then we are going to differentiate with respect to the exponents. Then we differentiate the terms to in the brackets. So when we differentiate, we will multiply the coefficients of this function by 5. So here we are going to have 5 times 2x cubed minus 1. Then we subtract 1 from this. So we are going to have 5 minus 1. Then we differentiate the terms in the brackets again. So we differentiate what is in the brackets. So when we differentiate what is in the bracket, we are going to have 3 times 2, which is 6x squared. So 2x exponent 3 will give us 6x squared. So when we differentiate this one, we get 0. Now, we multiply it by x squared minus 1 all exponents half plus 2x exponent 3 minus 1 or exponent 5. Then we differentiate this one too. So we differentiate with respect to the exponent. So we are going to have the exponent times the expression in the bracket. So we are going to have 1 on 2 x squared minus 1 dot. Then we differentiate the terms in the bracket too. So we are going to have x squared minus 1 being differentiated as 2x. So we multiply the coefficient of x by 2. Alright. So this gives us 5 times 2 exponent 3, 2x exponent 3 minus 1 exponent 4 dot 6x squared dot x squared minus 1 or exponent half plus 2x squared minus 1. Sorry, when we differentiate this one, we didn't subtract. So when we subtract 1 from here, we are going to have negative 1 on 2. Sorry. So we are going to have negative 1 on 2. So 2x squared minus 1 exponent 5 dot 1 on 2 x squared minus 1 exponent negative 1 on 2 dot 2x. Okay, so this gives us, now we can see clearly that if we multiply 6x squared by 5, then we are going to have 30x squared times 2x exponent 3 minus 1 exponent 4 times x squared minus 1 exponent 1 on 2 plus, then the second one 2 gives us, now when you check carefully, 2 can cancel 2, so we have x into bracket 2x squared 2x cubed minus 1 exponent 5 times x squared minus 1 exponent negative 1 on 2. Now, can we spot factorization here? Yes, so you see that we can factor out x into brackets 2x exponent 3 minus 1 of exponent 4, because here we have this one to be exponent 4 and this one is exponent 5. So we can bring the one with the least exponent out. Then we have x squared minus 1. Then we have x squared minus 1, 2 here. But we know that negative 1 on 2 plus 1 will give us half. So we can bring negative 1 on 2 out too. So therefore, let's factorize. Okay, so now what we do is that we bring our terms alike out. And that in that case, we are going to have x into bracket 2 exponent 3, 2x exponent 3 minus 1 or exponent 4. So we bring the one with the least exponent out times x squared is common in both. So we have x squared minus 1, x squared minus 1 2 as well. X squared minus 1 exponent negative 1 on 2, as we have already stated over here. Then we bring the unlike terms in. So we are going to have 2x cubed minus 1. Alright, so here we are left with, let me bring the first one here. So we are left with 30x. Now x is out, so x times 30x will give us 30x squared, and now that is what is here. So we bring 30x out. So we bring 30x out, x squared minus 1 plus, then here too we are left with 2x exponent 3 minus 1. Okay, so now let's further expand this. So we have this one, x into brackets 2x exponent 3 minus 1 exponent 4 x squared minus 1 or exponent half. Then we expand what is here. So we are going to have 30x times this one, giving us 30 x cubed 30x minus 1 giving us 30x plus 2x cubed minus 1. So this is the final result for our differentiation. Now you can try the question 4 here, then submit your answer at the comment section for verification. Thank you, and don't forget to subscribe to our channel.